Hello, on this episode I'm going to show us how to plot the graph for this experiment on extension of a vibrating spring and proof of Hooke's law. So just watch. So a quick reminder of what our table of values is going to look like. So it's going to have readings of the mass, which is going to be 50 grams for the mass hanger, and then added weights of 20 grams for each mass hanger. Okay, now for us to plot our graph, we're going to plot the mass against the extension. So for mass against extension, for the y-axis of mass, I chose 20 grams to represent 1 unit, or 1 unit to represent 20 grams. And then for the x-axis, I chose 1 unit to represent 2 centimeters. So the first reading is 50 grams to 13. So we'll locate our 50 grams. This is 50 grams is going to be somewhere around here. To 13. Where is our 13? The 13 is going to be around here. So we're going to use a ruler to locate it. So I've done that, and this is the first point, as you can see. So the second point is 70 grams to 15. 70 is around here, and 15 is around here. So let's locate it. So this is the point, second point. So the third point is 90 grams to 17 centimeters. 90 grams is somewhere here, 17 is somewhere here. Okay, so we locate the points here. Okay, so the next point is 110 versus 19. 110 versus 19. Okay, 110 is somewhere here, and 19 is somewhere here. So I've drawn those 2 points, and they meet at this point. Okay, then the next point we have is 130. So it's somewhere here on the y-axis versus 21. 21 is somewhere here on the x-axis. So we use our ruler and pencil to extend the points upwards. So now that we've gotten our 5 points, we're going to draw a line joining the points. We'll join this line. That's our slope. So this is our line. Okay, so how do we find our slope? We find our slope by locating any 2 points on the line and drawing a triangle. Okay, so we can take this point and this point. Okay, so we'll draw a triangle out of it. So now we've drawn our triangle to create a gradient. So the gradient is the change in y all over the change in x. We chose 2 points, remember, and then we'll find it. So we say the slope s is equal to the change in y all over the change in x. So the change in y is, this point is what? 110. 110 minus 50 all over, for x we have 19 minus 13. So that will give us 110 minus 50 gives us will give us 60. 19 minus 13 will give us 6. Okay? So if you divide through, we'll have our slope is equal to 10. So that's it. So now the second graph we are plotting, this was a graph of M versus against what? E. The second graph is M against T square, which is the period, right? So now we'll use the same scale we used in the first graph, right? So we'll write 20, 40, 60, 80, 100, 120, 140, and 160. Okay, we have 0 here. Remember, it's 0 here. So now our T square is 0.138 to 0.223. Okay, so we're going to choose a scale. What scale are we going to choose? I guess I'm going to say, let's use a scale. Let's use a scale of 0.02, right? 0.04, 0.06, 0.08, 0.10, 0.12, 0.14, 0.16, 0.18, 0.20, 0.22, 0.24. Okay, so that's what we're going to use. This is what we're going to use. So our first reading is 50, right? So 50 is somewhere here. Then T square 0.138, okay? So 0.138 will be somewhere here, close to 4. The center will be 0.13, okay? So 8 will be somewhere here, or 9, okay? So this is the point. This is our point. So we are going to extend the line on the two sides to intersect at the point. So we have gotten our first point on the graph. Now the second is 70 and 0.164. So this is 70. 70 is between 60 and, no, we didn't get this first one. This is 70. That means the first point is meant to be 50, right? So we'll say 50. Okay, so it will be somewhere here. This will be the first point. This will be our first point. So we're going to erase this part. I'm going to just quickly erase this part, okay? So the second part is 1.64, okay? So this is 1.6. In between is 0.17. In between is 0.17. So we need 0.164. So it will be somewhere here. 0.164. 161, 2, 3, 4. Okay, so it's going to be less than half. So we'll take that up to here. Okay, we'll extend this line here, and this is our second point. Okay, remember our first point is somewhere here. 50. Okay, we're extending it. Okay, so now the third point is 90. Okay, 90 and 0.79. So this is 90. 90 is between 80 and 100, which is here, and 0.79 is going to be somewhere here, close to 0.18. Okay, so let's just put it somewhere close to the line. So that's going to be somewhere here, just very, very close to this line, very, very close to this line. So that's the point, the center. Okay, so let's extend this. We're extending this. Okay, so our next point is 110. 110 is somewhere here. 110 versus 0.228. 0.228. 0.228 is close to 0.3. Okay, 0.3 somewhere here. So it's gonna be something 228. It's gonna be somewhere here. Okay, it's not so difficult, so don't be afraid, don't be scared. It's just, you just have to be very careful, that's all. Very careful not to make mistakes. Okay, so this is our fourth point. This is our fourth point. Okay, so our last and final point is 130. 130 versus 0.233. Okay, so this is 0.233. 0.233 should be somewhere here, very close to the last point we located. Okay, so we're extending it upwards. Okay, so this should be our point. This should be this is our 130. Okay, so this is our line. It's more like a curve, so we're going to do something about the curve, something like this. Okay, so we're asked to find the slope of this line. Okay, so we're going to draw a tangent to this line, a tangent. We use our ruler and draw a tangent. Okay, so this is our tangent. Okay, so to find the slope, we'll look for any point on the line. Let's choose this point and draw a line, a triangle. Okay, and this other point, let's choose this point. Okay, we'll join it. So we are finding the slope of this. Okay, change in y all over change in x. So our slope is equal to change in y all over change in x. Our first point for y is at 110. 110. The second point is at 90. Okay, 90. Okay, then for x, the first part is at this point. Okay, so that should be, if it's at this point, that should be 0.20. The center will be 0.21, right? So let's say 0.21, 0.21, 212. 0.212 minus, the second point is going to be somewhere here on the x-axis. That's the middle, right? So that would be 0. That would be 0.19. So this will give us what? 110 minus 90 will give us 20. Then 0.212 minus 0.19 will give us what? We'll have 2 at the end. And we have 2 at the end. 0.022. Okay? So our answer is, so the slope for the second graph is this, 909.1. So this is how to get your graph, your table of values and your graph, how to plot your graph and how to find the gradient of your slope for a vibrating spring. Thank you for watching. See you next time and good luck in your NECO examinations.